Most of you are probably familiar with the term sequence from your work with Professor Karpinski's Oral Skills Manual. There you were frequently called upon to rehearse sequentials, in which a basic musical idea is repeated at a different location in the scale. That's all a sequence is, a musical pattern that repeats at a higher or lower register. The effect, you'll note, is like making a copy of a shape and then reprinting it. Here's a basic melodic sequence. It's clear in this case the model is here, and that this model is repeated up a step in every subsequent measure. Indicate the model with an M, subsequent copies with C. You'll note that the copy is not perfect. The diatonic key of B flat controls, which means that the intervals actually shift a little bit from measure to measure. Between the second and third note of the first measure, there's a little minor second here. But when that gets shifted up to the next measure, it's actually a major second. That's the case here as well. So there are no accidentals, but the overall B flat controls everything. So again, it's a diatonic sequence, and that's the type that we'll be studying for the next week or so. The other thing that's important to realize is that the model, and this is something I said earlier, is repeating up a step each time it repeats. So indicate that by saying there's an ascending step here, an ascending step here, an ascending step here. This is something you intuit when you sing a passage that's so basic as this. So now we'll expand our notion of sequence to include chord patterns as opposed to just melodic patterns. Our model for conceiving diatonic harmonic sequences will be a two-chord model that's copied so that it repeats up and down within a key. And remember, there will be no accidentals, at least for the time being. Here's the simplest example there is of this procedure. You'll note the extreme sing-song patterning of this famous tune. We could go so far as to provide Roman numerals for this example. We'd say it's a 1 chord, a 4 chord, a 7 chord, a 3 chord, and we'd go on and on. We'd actually make it a full circle through all of the Roman numerals. But that approach is of varying use depending on what kind of sequences are present. And it doesn't reflect the reality of the patterning, the models, and the copies. So instead, we're going to discuss musical phenomena like this in even more basic terms. What I would ask of you is, where is the two-chord model, and where are the copies, and by how far do they move each time the model repeats? So the basic approach to labeling and analyzing sequences will be just that. First we'll ask, where is the model? It's right there. Where are the copies? They are here. We'll say there's a model, copy, copy, and copy. And in this case, we're more interested in the fact that the model repeats down a step in each measure. We started on a D chord at the downbeat of this measure, a C sharp chord at the downbeat of this measure, a B chord at the downbeat of this measure, and an A chord at the downbeat of this measure, telling us that we're always descending by step each time we have another copy. The fact that we're going to relinquish Roman numerals and discuss things in terms of chord roots and distances and going down by step actually requires a whole new mode of thinking. So we're going to have to practice this. We have a vocabulary that's going to help us name and describe sequences. So the first thing that we'll do is practice thinking in chord roots. We'll be limited to the 6 intervals of ascending second, descending second, ascending third, descending third, ascending fifth, and descending fifth. That's just to simplify things. All motions between chord roots can be described in terms of these intervals. Now we'll practice labeling chords according to their root and then identifying the distance between them. The approach here is to use what I'll call classical lead sheet symbols, which signify pretty much all the same information that a Roman numeral would, except no Roman numeral, no actual functionality within a key. We'll describe the chords based on their root name, their quality, and their inversion. So we can do that first. Given the first two chords here, we could say that we have a C chord and an E chord. In the second example, we have a C chord in first inversion and an E minor triad. Here we have a C chord and a D chord in first inversion. And notice that I indicated that it's minor. Here we have a D chord in first inversion and a C chord in first inversion. Here we have an E chord, which is major in first inversion, and an A chord that's minor. And last we have an F major chord and a C major chord, both in root position. We'll consider each of these as a pair and play that game where we identify the structural interval second, third, or fifth in between those two letter names. So if I'm going from a C to an E, you know that to be a ascending third. The distance from a C6 chord to an E6 chord, notice that the bass doesn't even move. On the surface of the music, you might say, well, the bass isn't moving. But the chord root is changing from being a C chord to an E chord, which means that it is similarly an ascending third motion, the distance from C to E. I don't care about the inversions at present. We'll bring that information back soon. The motion from a C chord to a D chord is fundamentally an ascending step, no matter what inversion. The motion from a D chord to a C chord is the reverse. Going from D to C is actually a step, but in the downward direction. Moving from an E chord to an A chord is a descending fifth. And moving from an F chord to a C chord is also a fifth, but it's moving in the ascending direction. You might be tempted to call that a descending fourth, but we are limited to seconds, thirds, and fifths. In labeling sequences, we have to keep track of two distances. Both of the distances are measured by chord roots and by the intervals, the 6 intervals that we talked about. The most important information is the big picture item referring to the interval between the model and the copies. That's what we kept track of before. We said there was a model, and then every time it moved, it took the whole pattern and moved it by a certain interval. Then we will also look inside the model and peer inside and see what is the fundamental chord root motion within. And those are the two pieces of information that we will put together in our sequence label that will take this format. It'll be an interval above and an interval inside. To practice that, I'll return us to our bingo progression, but this time it will be in minor. It's virtually the same thing. In this case, we'll want to identify the models and the copies, and we will need to rely on those classical lead sheet symbols. By ear, we hear that to be the model. Here is a copy, here is a copy, and here is a copy. The other thing we're going to need are the names of all of the chords based on their root, quality, inversion. A D chord, a G minor chord, a C major chord, an F major chord, a B flat major chord, an E diminished chord, an A major chord, a D minor chord. To apply the same intervals as we did before, first we ask, what happens to the model every time it repeats? Making any note-to-note comparison or chord-to-chord comparison, we see a D chord goes to a C chord, goes to a B flat, goes to an A. Each time this sequence repeats, it's moving down a step. Now I look within the model, and I ask myself, what is happening inside? What is the motion from D to G? What is the motion from C to F? And you will see each time it is a descending fifth motion, which is the most famous sort of sequence. It's known commonly as a circle of fifths. We will refer to that as a descending second controlling a descending five, a D2, D5. as it were. In review, a harmonic sequence is a 2-chord pattern that repeats. It's analyzed in terms of its chord root distance. The format of the label is 2 intervals, which refer to the models versus copies. And a second part of the label refers to the interval inside of the model and inside of the copies. And that is the introduction to analyzing harmonic sequences.